Hello and welcome to the new video series, Templates Defining End Conditions. In this series, we're going to cover the ins and outs of end conditions, the property of those end conditions and how those affect, how to create several advanced examples, and finally we'll discuss some common pitfalls. In this particular video, I will introduce you to what makes end conditions so unique and powerful, the properties of those end conditions and their effects, and how to control the processing order with priority. So, what is an end condition? The short answer is, it's the dirt. The long answer, it's the variable solution that ties your proposed pavement to the existing ground. Later on, we'll see how powerful and dynamic these can be. So, where to begin? There are really three core concepts to end conditions: point properties, component properties, and priorities. And once you have these three down, you're going to be creating end conditions like a pro in no time. Here I've highlighted the target type, and that's kind of the fourth core concept to end conditions, and we'll discuss that here in the next slide. So, what is a target and why is it important? End conditions always have a target. They seek, and that's what makes them unique. Here you can see we have our pavement that ties nicely into our existing ground. And over here, you see what happens if your end conditions do not solve or do not find their target. Our roadway is almost floating above the ground there and does not tie into our existing ground. Now typically you will see this because in this example I have forgotten to set the terrain model to active. So that's a common pitfall to avoid. By now you should be familiar with the point properties dialog. And here you can see that end conditions have just a few more properties in this dialog. So let's go take a look at how those operate. So for this example, I'm just in the template library. I'm going to quickly create an end condition component, and don't pay too much attention to what I have going on here. But what we want to look at are these four options right here. We have check for interception, place point, end condition is infinite, and do not construct. So I'm just going to clear these first of all, and data point to place a point out here. Right click to finish. So there's a quick end condition. Now what we can do is take a look at its operation. I'm going to click the test button here. And now we can see our end condition does not display, and that's because it hasn't found its target yet. If you'll notice in the test dialog we have an available targets list, and any end condition component that has a target, that target will be listed in this dialog. One thing I like to do is set this to something other than 0. That sometimes reveals hidden errors. So I'm going to click the draw button, and now what you can see is this white line, and if you can imagine that being a cross-section of our terrain model, and you can see that this first toggle with all our checkboxes off, all that does is see if the end conditions target is present, and it is. So that component displays. So I'm going to close this. I'm going to double click on this point to bring up its point properties, and now let's check the check for interception toggle. I'm going to apply that, close it, and retest. And now what you'll see when I hit the draw button is that that end condition component only displays when the terrain actually intercepts that end condition component. Go back to the dialog, and I'm going to edit that point. I'm going to now toggle on the place the point at the interception. I'm going to apply and close, test again, hit the draw button, and now what you'll see is not only does the end condition only draw when the terrain model intercepts it, but it stops drawing at the point of interception. So this is where you get your tie-in to the existing ground nicely. So I'm going to close that, double click on our point again. Now we're going to make that end condition infinite. Apply that, close it, test. I'm going to draw, and now you can see that even though we drew that initial element only out to about here, because we've set it to infinite, it will go out as far as it needs to tie into the existing ground. The one final point that we have is the do not construct property, and I'll go ahead and toggle this on and apply it, but what that's going to do actually is set up a scenario where no matter what, the point doesn't draw. The in condition solution doesn't draw. So we use do not construct in some pretty special scenarios, and we actually cover a couple of those later on in the video series. Now, let's go take a look at component properties. By now, you should be familiar with the component properties dialog and most of those settings. If you haven't viewed our other videos on this subject, I suggest you go back and get some background information. The properties for an in-condition component really are not all that different, and you can see there's a few additional properties here which we'll cover, one of the most important one being the target type. What I've done here is opened up one of the combined in conditions delivered with the default workspace. And what I want to do is just double click on one of these components here. And you can see the in condition properties here. We have a target type. And notice that we have several different target types. We can typically, what we want to do is tie into the existing ground with our in conditions, but you can also target an elevation. You can also look at a linear element within your drawing, and you can either use the horizontal component, the vertical component, or both. Likewise, you can target a feature definition and use its horizontal component, its vertical, or both. Notice too that you can actually key in a value for the terrain model. I highly suggest you don't do that. And the main reason is it limits the usefulness of your template. The other thing to look at or to notice here is the priority, and we'll be discussing this in more detail next. So now I'm going to test. So what you can see here is what we referred to as a multi-branch in condition. So we have several branches or several slope solutions coming off of a single hinge point. They are all trying to target the active terrain model. So I'm going to go ahead and select my terrain model, click the draw button, and now you can see due to the point properties, those slope solutions cycle in order, with the last ones being infinite. Same thing on the fill side. So how does the software know what order we want these slopes to be processed in? That's done through the priority setting. So let's go examine that. Typically, the less earth you move, the cheaper your project is going to be. So you're going to have some ideas based on your standards on the ideal cut and fill solution and what you can live with. With the priorities dialog, you can set that up to process in the order that you want. You can either set that under the component properties or within the check properties dialog, and we'll cover that. One thing to note, however, is that the order in which they process is ascending. So it's going to start with the first option, or number 1, then it's going to go to the second option, the third, the fourth, the fifth, and so on. So as it processes this table, it counts up. So your highest priority, or the one that you want, will actually have the lowest number. Let's go see that in operation. So under the test dialog, we can actually check the priorities of our components here. So I'm going to select that. Typically, this button is used to correct errors in our processing as we're creating our templates, but in this instance, we would just want to go in and edit those. And again, I was talking about a single hinge point, so all these in-condition solutions come from a single hinge point or a branch point. So I'm going to edit that branch point. So the first solution that we have is a 6-to-1. And then it'll go to the 4-to-1. If that one fails, it will move on to the 3-to-1 and finally the 2-to-1. Likewise, if it doesn't find any on the fill side, it will slip up to the cut side with a 6-to-1. If that doesn't solve, it'll go to the 4-to-1, the 3-to-1, and finally the 2-to-1, which is infinite. So I hope this has taken some of the mystery out of in conditions. So they really are just points and components with a couple extra attributes. The test dialog, as you can see, is a very useful diagnostic tool when you're working with in conditions. Later in this series, we'll look through some examples and illustrate how varied and powerful in conditions really can be. I hope to see you there.